In this video, I'd like to go over question number 2. So question number 2 talked about the study conducted to compare the blood sugar level after taking metformin or the placebo. Okay, so group 1 is the placebo and group 2 is metformin over here. So for each group, we have 5 subjects. So their corresponding glucose level has been measured. So over here. So we also have the mean and the SD and also the pooled SD. So the first one is calculate the effect size. So the equation is simple. So basically the difference between these two means over the SD pooled. So the pooled SD over here. So you just need to plug in the number. Then you should be able to get a number equals negative 0.887. So here be careful if you have to use a two-sided test. So which actually is most frequently used. So you have to use absolute value for depending which software you are using. Okay. For SPSS, if you use two-sided, then you have to use a positive value of this one. So now let's move to the SPSS. So the first thing you can copy the data over. So we have group 1, group 2, their glucose level. So you can modify this. So the group 1 we call is actually is treatment, right? And group 2, we can say glucose level. And of course, over here for this one, we can change the value, right? So group 1 is placebo. And group 2, metformin. Okay. And for this one, for the group 1, basically nominal, right? Because two groups, and group 2 is just numbers, right? So it's a scale, right? So for this one, of course, the group 1, we don't really need decimals, right? Okay, now it's like this, so we can make it larger. Okay, so you can see. So now let's compare the difference. So usually we can, for the two groups, we can use student t-test. So over here, let's do the compare the mean because we want to compare the mean difference, right? So compare means and the proportion. So over here, so the student t-test, basically also we can call it as independent sample t-test. So these two are the same. So the treatment basically is a group variable, right? And the treatment we have 1 and 2, right? Because it's automatically recognized already, so you don't have to modify this. And we want to test the variable glucose level. So now, okay. So you can see this the results over here. So the first one is to test the equality of the variance, right? So greater than 0.05. That means we can consider they are kind of equal, right? So for this table, so the most important part is actually is over here. So usually we use two-sided t-test. So the two-sided p over here, p-value is 0.9197, right? So this is the most important one, okay? So the Cohen-D also you can check, right? Cohen-D is 0.887 because it's two-sided. So usually they use the absolute value. So that means you will get a positive value. So over here. So now let's see the next one. So over here. So because we know that p-value less than 0.05, right? So that means there's no statistical significance, right? But of course, we know that the metformin definitely has been used such a long time. Definitely it can reduce glucose level, right? So even we got a p-value greater than 0.05, does not necessarily mean it. I mean, there's no difference, right? Because probably that's only because we don't really have enough sample size, right? So whether or not, so we can do a further study. So let's move on to this one. So analyze power analysis. So again, it's me. So for this one. So in this case, okay, so you can either use the effect size because we already calculate. That means it's pretty straightforward. It's easier, right? So we want to calculate the power. So group 1 and a sample size 5, group 2 same, right? So 0.887, that will be the effect size. So two-sided, right? Let's see. Okay. So now we have like a power 0.236, right? So what does this mean? So that means it's around like 23.6%, right? So we know that power means even these two, we know the metformin would be effective, right? But actually, because smaller sample size, we only have n equal to 5. That means even it is true, metformin is effect. But based on the current study design, we only have 23.6% of a chance to find out. Okay, so that's this one. So you can relate this one to like the type 1 or type 2 error. You can think about that first. Okay. So now, in order to really find the positive effect correctly, so then one thing we can calculate is a sample size. Okay. So how to calculate the sample size? So the same thing. So power analysis, mean, independent sample t-test. Okay. So sample size. So now let's see how many subject we need, right? So the power usually we put at 0.8, so that means beta equals to zero point 0.2, right? Then the significance level is 0.05, right? So in this case, let's see. And then because the group size are equal, right? So we just put the ratio as 1. So now let's click OK. So here we go. So in this case, if you have an equal size of the subjects for each group, then that means we have to recruit at least 21 subjects for each group. So which allow us have a much better chance to find out the difference, the real difference. Okay.